teacher Marian. In this section, we will talk about the first lesson in Quarter 4, Module 2, which is Quartiles for Grouped Data. For this lesson, we're going to discuss quartiles for grouped data. As a review, grouped data is the data that has been bundled together in categories. Histograms and frequency tables can be used to show this type of data. So if you encounter data that is grouped together by bins or classes, then that is a grouped data. The difference between the grouped and ungrouped data is that ungrouped data is raw. It's not sorted into categories, classified, or otherwise grouped. So basically, ungrouped data is a list of numbers like the examples found in Module 1. Finding the quartile value for grouped data is as easy as 1, 2, 3, as we will only be following 3 steps. Step 1. Complete the frequency distribution table with these corresponding columns: class intervals, frequency, lower class boundaries, and less than cumulative frequency. Step 2. Determine the quartile class interval using the formula Kn over 4, where K is the nth quartile, in which n could be equal to 1, 2, or 3. N is the total frequency. Step 3, or the last step, calculate the quartile value using the formula Qk is equal to Lb plus the quantity of Kn over 4 minus Cfb over Fqk times I, where Lb is the lower boundary of the Qk class. I is the size of the class interval. Cf sub b is the cumulative frequency of the class before the Qk class, and F sub Qk is the frequency of the Qk class. So now let us try these steps in this example. Calculate the Q1 and Q2 of the mathematics test course of 50 students given this frequency table. First step is to complete the table. Since the class intervals and frequency are given in the problem, so we only need to fill in the remaining rows in the lower class boundaries and less than cumulative frequency columns. But before that, let us get to know first what is a class interval and frequency. Class interval is the difference between the upper class limit and the lower class limit. Highlighted in red are the lower limits, while the part that is highlighted in blue are the upper limits. So in the class interval of 46 to 50, the lower limit is 46 and 50 is the upper limit, and so on. While frequency is the number of times the observation occurred or recorded in an experiment or study. So for the class interval 21 to 25, it means there were 6 students who got a score of 21 to 25. Same goes to the other entries in the frequency column. To get the value of n, we will sum up all the entries in the frequency column. The sum of 4, 8, 11, 9, 12, and 6 is 50. So the value of our n is 50. Now, let us proceed to getting the lower class boundaries. LB, or lower boundary, is the sum of the upper limit of the previous class and lower limit of the given class divided by 2. Or in simpler way, you just have to subtract 0.5 from the lower limit of the given class. So let's start from the bottom. The lower limit for the class interval 21 to 25 is 21. So 21 minus 0.5 is equal to 20.5. Next, 26 minus 0.5 is equal to 25.5. 31 minus 0.5 is equal to 30.5. 36 minus 0.5 is equal to 35.5. 41 minus 0.5 is equal to 40.5. And the last one is 46 minus 0.5 is equal to 45.5. And there you have it, the values of the lower class boundaries. For our last column, the less than cumulative frequency is obtained by adding successively the frequencies of all the previous classes along with the class against which it is written. Technically, A cumulative frequency distribution is the sum of the class and all the classes below it in a frequency distribution. In this type, the cumulate begins from the lowest to the highest size. So we will start from the bottom. The first entry will be the same as the first entry in the frequency column, which is 6. The second entry will be the sum of the first two entries in the frequency column. So 6 plus 12 is 18. Let us fill in the rest of the cumulative frequency column in the same way. 18 plus 9 is equal to 27. 27 plus 11 is equal to 38. 38 plus 8 is equal to 46. And 46 plus 4 is equal to 50. Remember that our last entry for this column should be equal to the value of our n, which is the total frequency. Since we are done completing the table, then let us proceed to step 2. Determine the quartile class interval using the formula Kn over 4. Remember that our K is the nth quartile and n is the total frequency. So for Q1, the value of K is 1, while for Q2, the value of K is 2, and n is 50. So let us substitute the value of K and n to the formula. For Q1 class, we have here 1 times 50 divided by 4. 1 times 50 is equal to 50, divided by 4 is equal to 12.5. This means we need to find the class interval where the 12.5th score is obtained. This 12.5th value of observation can be found in the less than cumulative frequency column. Note that the 7th to 18th scores belong to the class interval 26 to 30. So the 12.5th score is also within the class interval. The Q1 class is class interval 26 to 30. For Q2 class, we have here 2 times 50 divided by 4. 2 times 50 is equal to 100 divided by 4 is equal to 25. This means we need to find the class interval where the 25th score is obtained. Note that the 19th to 27th scores belong to the class interval 31 to 35. So the 25th score is also within the class interval. The Q2 class is the class interval 31 to 35. Since we already determined the Q1 and Q2 class, then it's time for us to do the last step, which is to calculate the quartile value using the given formula. For Q1, we will have this. Of course, before doing the operation, we need to provide first the value of the variables which are present in the formula. So for the lower boundary or LB, let us look at the table in step 1. The lower boundary in Q1 class is 25.5. For the value of our I, or the size of the class interval, we have to find the difference between the lower boundaries of two consecutive or neighboring classes. Example, these two consecutive lower boundaries 45.5 and 40.5. So in order to get the size of the class interval, we have to subtract 45.5 to 40.5, and that is equal to 5. Depending on the author, we can also use the difference between the lower limits of two consecutive classes in the value of the class interval. So let us have these two consecutive lower limits, 26 and 21. So 26 minus 21 is equal to 5. Still, we will arrive with the same answer. In other words, you can make use of either ways in getting the value of I or the size of the class interval. Next is the value of the CFB, which is the cumulative frequency of the class before the QK class. Since the cumulative frequency of Q1 class is 18, then the cumulative frequency before 18 is 6. So the value of our CFB, or the cumulative frequency of the class before the QK class, is 6. Lastly is the FQ1, which is the frequency of the QK class. So for Q1 class, the frequency is 12. Similarly, in finding the Q2 value, we will use this formula. For the lower boundary or LB, let us look at the table in step 1. The lower boundary in Q2 class is 30.5. For I, or the size of the class interval, the value is 5 since we get the difference between the lower boundaries of two consecutive or neighboring classes. For CFB, the value is 18 since the cumulative frequency of Q2 class is 27. Then the cumulative frequency before 27 is 18. For Q2 class, the frequency is 9. This time, let us perform the operation by substituting all the given in the formula. Remember that the value of the expression kn over 4 can be found in step 2. So for Q1, the value of kn over 4 is 12.5. Let us do the operation. Q1 is equal to 25.5 plus the quantity of 12.5 minus 6 over 12 times 5. So 12.5 minus 6 is equal to 6.5. 6.5 divided by 12 is equal to 0.542 times 5. The result is 2.71. Let us add 25.5 and 2.71. And the resulting value for Q1 is equal to 28.21. For Q2, the value of the expression kn over 4 in the formula can still be found in step 2. So for Q2, the value of kn over 4 is 25. So let us do the operation. Q2 is equal to 30.5 plus the quantity of 25 minus 18 over 9 times 5. 25 minus 18 is equal to 7. 7 divided by 9 is equal to 0.778 times 5 is equal to 3.89. Let us add 30.5 and 3.89. And the result is 34.39. Therefore, the value of our Q2 is 34.39. And that's all for this lesson about quartiles for grouped data.
Maraming salamat sa panunood, mga kaalamat!